What if I told you that aliens exist and are not a myth or legend? This video isn't about conspiracy forums or Hollywood monsters. It's about real scientific signals, strange, unexplained observations, and the honest, careful work researchers use to separate hope from evidence. Stay with me because we walk through the strongest types of evidence we already have the hard test scientists demand before they say yes. And the dramatic changes a confirmed discovery would force on science, society, and how we see ourselves. By the end, you'll know why this question is one of the most urgent in modern science. Start with the simplest idea. Not all evidence is equal. Some sightings are eyewitness stories or blurry footage, emotionally powerful but scientifically flimsy. Move from that to the stronger categories: biological signals, signs of life; technosignatures, signs of technology; and physical artifacts. Each class has different standards and different ways to be validated. On the biological side, the clearest path is something reproducible. Chemical or structural features that strongly point to life, for example. Repeated detection of complex organic molecules with patterns that chemistry alone can't explain. Lab-grade isotopic ratios, microfossils, or metabolic activity measured in a sealed, contamination-controlled environment would be the gold standard. Those are rare and require careful contamination control. Earthly microbes are sneaky contaminants. Technosignatures are a different beast. Narrowband radio pulses, tight optical laser flashes, or engineered megastructures would scream artificial origin, especially if they carry information, prime numbers, encoded sequences. SETI has hunted radio for decades with few clear candidates. The bar is high because many natural processes mimic narrow signals, and human radio leaks can confuse the picture. Then there's the UAP question: airborne/unidentified phenomena recorded by sensors. Most cases reduce to misidentified craft, sensors, or atmospheric phenomena when cleaned up. A tiny subset remain unexplained because data are incomplete. That's a signal for scientists, not proof of aliens, but a prompt to get better instruments and independent measurements. In short, strong evidence is repeatable, independently verified, and inconsistent with known natural or human causes. Anything less is just intriguing, not definitive. If you want a checklist for conviction, start with replication and independent verification. A single odd signal, even a stunning 1-1T, convinced the community until it's reproduced by different instruments and teams. That's why lab return samples, simultaneous multi-observatory detections, or replicated in situ experiments are critical. Take a hypothetical claim: a meteorite with microfossils. The first step is multiple labs using different techniques: electron microscopy, isotopic analysis, organic chemistry, to show the same patterns and rule out Earth contamination. If isotopic ratios strongly deviate from abiotic expectations and microstructures show biological organization beyond random mineral growth, the claim gains traction. That level of scrutiny is slow and painstaking because extraordinary claims need extraordinary checks. For technosignals, the protocol is similar. Different radio telescopes must pick up the same pattern coming from the same sky coordinates, with a structure inconsistent with known astrophysical sources. If the signal contains non-random encoded information, say, an unequivocal sequence of prime numbers, that changes the conversation overnight. But the field has learned caution. Pulsars and natural masers once masqueraded as artificial signals until properly understood. For UAPs, or anomalous sensor data, what scientists demand are raw, unprocessed data streams. Multi-sensor fusion, radar, infrared, visual, time-synced, and ideally instruments that can be aimed quickly for follow-up. Better data mean better analysis, and better analysis often resolves apparent mysteries without invoking aliens. The pattern is consistent. More and cleaner data, independently analyzed, is how science separates awe from evidence. Imagine the moment we pass from maybe to confirmed. The implications would ripple across science, philosophy, religion, and geopolitics. First, the scientific revolution. Biology would expand beyond a single data point, Earth, forcing new theories about life's origins and distribution. Astrobiology would become an experimental, not purely speculative, discipline. Practically, it would reshape missions and budgets. Funding agencies would prioritize sample return, planetary protection, and deep space observatories. International collaboration would spike because handling biological and technological discoveries requires shared protocols and trust. We also need robust planetary protection rules to avoid contaminating other worlds or bringing dangerous unknowns back to Earth without containment. Culturally, we'd face big conversations. How different societies interpret the discovery, how media frames it, and how misinformation could spread. Responsible communication would be essential. Scientists and leaders would need to provide clear, measured explanations to avoid panic or exploitation. Ethically, questions about contact protocols, rights of discovered biospheres, and whether to transmit messages back would demand global debate. Finally, the so what? Confirmation that life exists beyond Earth would answer one of humanity's most ancient questions, and simultaneously raise deeper ones about meaning, rarity, and destiny. Even a microbial discovery rewrites our cosmic story. If it's technological life, the stakes and decisions become exponentially more complex. In every case, the first step is the same: careful science, transparent processes, and international cooperation. So aliens might be more than myth. We already have hints and unexplained data. But the scientific pathway to certainty is strict: replicate, rule out mundane causes, and verify independently. Whether the next leap is a laboratory confirmation from returned samples, a repeating technosignal, or a multi-sensor UAP dataset that survives scrutiny, the process will be slow, deliberate, and glorious when it happens. If you like this deep dive, tell me in the comments. Which would you fear more: proof of microbial life everywhere, or a single intelligent signal from across the stars? Hit like, share with friends who love cosmic mysteries, and subscribe to join the Planet X community. Thanks for watching. Your curiosity keeps this journey going.